Hello everybody. In this video, I'd like to give you an example of how to do t-testing between two independent sample means. So let's look at an example. The first example is that independent random samples of 17 sophomores and 13 juniors attending a large university yield the following data on GPA scores. At the 5% significance level, do the data provide sufficient evidence to conclude that the mean GPAs of sophomores and juniors are different? So this is an example where the data actually gives us the scores for two different groups of people. So we could think of all of these scores as coming from a sample of sophomore students, so it comes from a sample of 17 sophomore students. And here you have a sample of 13 juniors attending a particular university. And the question asks us, is there sufficient evidence from this sample to conclude that the mean GPAs of sophomores and juniors are different at the university? So the population of all sophomores and juniors, so that's all sophomores and juniors in the university is the population. We only have a random sample from each group. And we're asked to check if there is any difference in the scores between these two groups at the population level. So naturally, we're going to look at the difference in means between the two samples here and check if any differences between them are whether this difference is evidence enough to conclude. I mean, we're going to explore the sample to see if the sample is suggestive that there is no difference between the two groups. Now, instead of doing this manually, Excel has a fantastic add-in package called so if you go into the data tab, there's something called analysis tools, and it's called the analysis tool pack. And I think in one of the earlier videos, I would have taught you how to add this add-in. If not, you can Google it, and it's very easy to know how to figure out how to do this. So you just have to ensure that you have added this analysis tool pack and make sure that it's added into your Excel. Then what you have to do is go into the data tab, click on data analysis here in the top right. And here you have an option where, when you scroll down to, it has several different options here, move down to t-test and choose this case where two samples assuming unequal variances. Okay, that's the option which we are learning about. So here we are assuming that the variances are different in each sample, and therefore you have to choose the unequal variances option. So just, there are different types of t-test you can do with two groups. In this course, we are only learning the one with unequal variances. So say OK. Now a dialog box opens up, and you're supposed to key in different, you have to choose different data values to go into each of those boxes. So what you see here is variable 1 range. Click on this icon. So variable 1 range refers to the values for the first group. Okay? So that will be these 17 numbers. So select the numbers for the sophomores. So that's the variables for the first group, and it will automatically be selected in the dialog box. Now click on this icon again to expand the dialog box. So we've chosen variable 1's range. Then go to variable 2's range. Click on this icon again. Now go ahead and choose the second data set. So that will be these numbers for the juniors. Go back here, expand on this. Hypothesized mean difference. So this is our mu1 minus mu2. And we are checking if there is any difference between the sophomores and juniors. And therefore, our null hypothesis is that there is no difference. Alternative is that there is some difference. So here, the hypothesized mean difference refers to the null, and you put in a 0. Alpha level is the level of significance. It's given to us at 5%, so we'll type in 0.05. Under output options, make sure you choose output range, and then you click on this, and you identify a cell in your Excel sheet, any cell just after the data set, and that is to instruct Excel that you want to paste the output there in that cell. So I've chosen that cell. I go back here, and then all I have to do is press OK. And that's it. It's run the test. So here is what it means. So variable 1 is the first column of the values that we chose, and Excel tells us that the mean of that column is 2.84. You can always check by just selecting this column and examining the values here. The average is 2.84. So Excel has calculated things correctly. And similarly, the mean of the second variable is 2.98. Well, it matches here. So that's the mean. And this is the variance for the first sample, variance for the second sample, number of observations in both cases, hypothesized mean difference. And it's calculated the degrees of freedom using a special calculation, which we don't need to be knowing. Now here, it gives us the t statistic, the t score for this particular two sample test. And you can look at the notes to see how you write down the t statistic expression. And then it gives the p-values for whether we are looking at a one-tail test or a two-tail test. So here, and it also gives you the relevant critical p-values, your threshold values. So here we're doing a two-tail test, so we'll focus on these numbers. The probability for a p-value for a two-tail test here is about 0.364. And we're told that the critical p-value is 2.0518. So this is our t alpha by 2 number, okay? Area to the right of this critical t value is equal to alpha by 2. And similarly, and that's all you need to know. And similarly, on the left side of the tail, you'll have your corresponding critical value is minus 2.05. Area to the left of that point will be alpha by 2. Now, look at our t-stat here. The t-stat is minus 0.92. Minus 0.92 certainly lies in the interval between minus t critical to plus t critical. Or, okay, that may be a little bit complicated to visualize. Just look at the p-value. P-value is 0.36. Alpha is 0.05. P-value is certainly greater than alpha, and therefore, we do not reject the null. So we do not reject the null that the mean scores between sophomores and juniors are not different. So that's our conclusion. So our p-value is greater than alpha, so we don't reject the null. Therefore, we don't reject the null that the mean scores we don't reject the null that the mean scores are similar. So this is one example. Here's another example. Suppose we want to know whether or not the mean weight between two different species of turtles is equal. To do this, we collect a simple random sample of turtles from each species with the following weights. So these are all, there are about how many? 13 turtles in each sample, and they have actually weighed the weight of every single turtle in these two samples. Now we want to check if the average weight of, and each of these samples is this particular species of turtle. The hypothesis, null hypothesis, is that there is no difference in the mean weight of these two species. And we want to check that null hypothesis. So our alternative is that there is some mean difference. Okay, let's go and do a two sample t-test. The same process as before. And we're told that the significance level is 5%. So I will go to data analysis, toolpack, t-test, assuming unequal variances. Variable 1's range will be these 13 numbers. Variable 2's range will be these 13 numbers. Hypothesized mean difference is 0. Alpha is 0.05. Output range, I'm going to choose this to be this cell. And I'm going to say OK. There we have our answer. We have the mean variance of each of these variables, and we have a t-stat and a one-tail p-value and a critical value and a two-tail p-value. Now look at the two-tail p-value. It is 0.049, and 0.049 is certainly less than 0.05. Our p-value is lesser than alpha, and therefore we reject the null at 5% level of significance, that there is no mean difference in the weight of turtles from the two species. So essentially, you're rejecting the null that the two turtles, the turtles from both the species have equal weights. I'm rejecting that null. And that is how you do a two-sample t-test in a very simple way in Excel. I'll also show you how to do it using R. Just give me a second. Okay, so we're going to try and do the same thing, two-sample t-test using R. So let me just set up my directory to make sure everything is in order. Oops. Now we have the same first example where we're looking at the scores of sophomores and juniors and checking if there is any difference between the two. So I've keyed in all of the scores for the 17 sophomores here, and I've created a column vector. I have similarly created another column vector for the 13 juniors. Now, there's a very simple code to do a two-sample t-test, and that is just t.test. So you can do a search of that to see how to write down the arguments. I'll show you the syntax here. The simplest is you just put t.test within brackets. The first argument x is equal to your first sample, which is sophomores. Second argument y is equal to juniors, the second sample. Okay. And you could say the next thing you want to do is, this is a two-sided test. So you're going to say alternative is equal to two-sided. You need to say mu, which is the hypothesized mean difference. Okay, hypothesized mean difference is equal to 0. Then I'm just going to run this, and there we go. So here, Excel R is automatically giving us the key numbers that we want. So we have a t-stat, we have degrees of freedom, and we have the p-value. And because we already specified that we are doing a two-sided hypothesis, the p-value here is a p-value for a two-tailed test. And the p-value here matches what we saw in Excel. It is 0.3642. Because the p-value is greater than our alpha of 0.05, we can go ahead and reject it. Sorry, we can go ahead and we do not reject them. Okay. Now there's another, you can add a code which says you can specify the conf level. Okay. But generally the default is set at 0.05. I'll encourage you to look at, so confidence level is where you do 1 minus alpha. So here you do conf level is equal to 0.95. You run the test, you get the same answer. The p-value tells us that you do not reject this null hypothesis. And this test also shows you what the alternative is. It gives you a 95% confidence interval. And we see that the value 0 is contained in this confidence interval. And whenever the null value is contained in a confidence interval, you do not reject the null hypothesis. And that is how you do it in R. Let us look at the second example also. So we have the two different species of turtles, and we've sampled about 13 in each of them. And we want to check if the mean weight is different between these two species. So let me run these two lines. So we know I've put in the sample 1 and sample 2 vectors. Now let me do a two-sample t-test for x is equal to sample 1, y is equal to sample 2, alternative is two-sided, mu is equal to 0, conf level is 0.95. When I run this, I get the same results that we saw in Excel. Our p-value is 0.04914, and because this is lesser than 0.05, we reject our null hypothesis. But remember, and also if you look at the 95% confidence interval, it goes from -14 to -0.03, and this mean value of 0, hypothesized mean difference, is not part of the interval. And whenever your null hypothesized value is not in your interval, you reject the null hypothesis. Okay, So we reject at 5% level of significance. Now, just for the kicks, if we try running this at a 99% significance, let's see what we get. Our p-value will remain the same because by definition, we are looking at the probability of getting a more extreme test statistic. So the test statistic is not changing with your alpha level. The t-star will be the same. So p-value also doesn't change. But what you compare this p-value against has changed. So p-value is 0.049. Alpha is now 0.01. And now the p-value is greater than alpha, so we do not reject. We reject something at 95% level, but we cannot reject this at the 1% level of significance. And you could also see that in the 99% confidence interval, right? It runs from -17 to 2.6, and 0 is in part of this interval. And whenever your hypothesized value is part of an interval, we do not reject it there. So do not reject at 1% level of significance. So that is it. That is how you do a 2-sample t-test in R. So happy learning.